So in the last video that we did for finding the area between two curves, we compared it to, even though that we had to do an integration for the curves that we had, or for the graphs that we had, we kind of likened it to what you did back in geometry, where you had to, what we referred to there, find the area of a composite shape, where you uh, essentially had to subtract the area of some smaller shape from the inside of a bigger shape. And uh, that's essentially how we kind of ended the video, where we found the individual areas of each piece and then took the difference of them. Well, what this is going to look at here is going to look at the same two functions over the same interval, and the two functions are typed for you here in case you happen to have missed the first video for some reason, uh, where we had function f of, that was the quadratic, and function g, which was the linear function. And now we're going to be looking at, okay, well, how could we do this without having to go through quite so much work, without having to do two distinct integrations? And this is what we have here, where we say, okay, well, we can use our properties of integrals here and write it where we're taking the difference before we actually do the integration. So let's see how this one is going to work out. So I'm going to start this off here by saying the area is equal to the definite integral of 0 to 5. And 5, golly, I can't write a 5 nicely for some reason. 5, there we go, much better. And we're going to go ahead and just take those two functions and put them in there. So the first function was the quadratic, that was the bigger piece, and I'm going to say the negative 1/2 times the x minus 2 squared plus 6. And now we're going to subtract the line, which was 4 minus 1/2 x dx. Okay. So the first thing I'm going to do is I'm going to kind of do a couple things at the same time. On the quadratic, we are going to go ahead and expand the x minus 2 squared, and we're going to go ahead and distribute that. And we will wind up with negative 1/2. And when I expand and distribute the binomial term, I'm going to get x squared minus 4x squared minus 4x plus 4. And of course, we still have the plus 6. And then we're, for the second part, for the linear piece, essentially what we're going to do now is you can distribute the negative signs there. So let me go ahead and take off those, ooh, I didn't mean to do that. Let's just go ahead and take off those brackets, because we don't really need them anymore. And, okay, let's just fix all of this. Give me my, there we go. Integral 0 to 5, negative sign. There we go. Go ahead and distribute the negative sign, and that'll be minus 4 plus 1/2 x dx. And I forgot a parenthesis here on the 4. There we go. And now we will distribute the 1/2, the negative 1/2 into the parentheses. So 0 to 5. So that'll give me negative 1/2 x squared plus 2x minus 2. And the 6 and the 4, we can kind of go ahead and combine those. The 6 minus 4, that'll give me a positive 2 plus the 1/2 x dx. And essentially, this is just an exercise in combining your like terms now before we do our integration. And so what you're going to see here, the positive and negative 2 here, those are going to wind up going away. And the like terms that are going to be left, the x squared is the only x squared term. So we got negative 1/2 x squared. And when I say 2 plus the 1/2, that's 2.5. Or in this case, I'm going to write it as a fraction. 5 over 2x dx. And now we can perform the integration, which will give me a negative 1/6 x cubed, and then we'll get a plus 5/4 x squared, and of course we're evaluating it from 0 to 5. And now that we have that, it's time to start doing our substitution with our fundamental theorem of calculus here. Substitute the 5 first, and I'm going to get negative 1/6 times 5 cubed plus 5/4 times 5 squared, and then we substitute the 0, and I'm going to get negative 1/6 times 0 cubed plus 5/4 times 0 squared, and all of this simplifies to be 0. So that really doesn't do anything to the problem. So let's just go ahead and simplify what we have inside of the problem. So 5 cubed is 125, so that will give me a negative 125 over 6. 5 cubed again, in this case, will give me 125 uh, plus 125 over 4. And when we get our common denominator here and add our add the terms here, we're going to get negative 250 plus 375 with a common denominator of 12 in this case. And when we take the difference of the 250 and the 175, we get the 125 over 12 for our area where we take the difference of the two uh, integrations of the overall function. So that is the first video very much was a discrete process of finding this integration, finding this integration, and then subtracting the two areas or the two accumulations from each other. And here we're kind of incorporating the two functions where we're simplifying what we can in the integrand itself before we take the actual integral. Okay, so I'm going to go ahead and stop this video here. We'll pick it up in the next video where we're going to take a look at some more functions where we're finding the difference or the sums of two areas. So thanks for watching and take care.